List all possible rational zeros of f and find the zeros. In order to find the possible rational zeros of f, we need to first find the factors of the constant term, which in this case is 8, and put them over the factors of the leading coefficient, which in this case is 2. We do not worry about the signs in front of either one of those numbers because we are going to plus or minus those factors. Factors are numbers that go into that number evenly. Starting with 1, both plus or minus, 1 goes into 8. Next, 2, both plus or minus. 3 doesn't, but 4 does, both plus or minus. 5 doesn't, 6 doesn't, 7 doesn't, but 8 does. So these numbers are the only numbers that are factors of the constant term 8. We now put those over the factors of the leading coefficient, or 2, plus or minus 1, and plus or minus 2 only. Now creating the numbers that could be the possible rational zeros, we take the numbers on top, in this case we'll start with 1, and put it over the first number on the bottom, or 1. From those, we get a possible rational pair of roots plus or minus 1. We next put 2 over 1. That will give us plus or minus 2. Next we put 4 over 1. That gives us plus or minus 4. Then 8 over 1, which gives us plus or minus 8. We then switch to the other bottom number using all the top numbers again. So now 1 over 2 is plus or minus a half. Then 2 over 2, which is already 1, so we don't need to write that again. 4 over 2, which is 2. Again, we don't have to write another 2. And finally, 8 over 2, which is 4. And again, we already have a 4. So now we have 10 possible rational roots, all of these. So if this equation has any rational roots, it will come out of these 10. To find them, we are now going to graph. We first start by pushing the y equals x, or the y equals button, and we will put the equation in. Once we get the equation into the calculator, we will graph it. Here's the graph, and notice since we only have numbers between -8 and +8, we do not need to make our x-axis window any bigger than that. It appears that the number that's being crossed at the x-axis is between 1 and 2. Since in this case, none of the numbers that are possible rational roots are between 1 and 2, this equation has no rational roots, and the solutions that we see are irrational or complex. Had it looked like the graph went through one of the numbers in our list, we could have used synthetic substitution to see if it worked. We could also check in our calculator with our table and in the table set portion.